Energy is an essential part of all our lives, whether it's at home, at work, or at play. 70% of us are going to be living in towns and cities by 2050. To make this sustainable, we will need to find better ways to communicate, move around, manage our buildings, and get energy into our cities. The way we get our energy is already changing. The UK grid is becoming a diverse network of different energy generation sources so that we can meet our evolving demands. For example, electric vehicle charging.
We need new solutions so that we can integrate, store, distribute and make better use of our energy.
Manchester City Council have declared a climate emergency. They have made a commitment that the city will be carbon neutral by 2038. We will need serious innovation on a citywide scale to ensure this target is met. The good news is, our city, Manchester, is one of 6 locations involved in the Triangulum project, an EU Horizon 2020 funded exploration into smart cities. Siemens has been working with Manchester City Council, the University of Manchester and Manchester Met University, focusing on energy in the Oxford Road corridor area. They are looking at how to balance demand and energy consumption, reduce carbon emissions and costs, and increase the use of renewable energy. Let's go and visit some of the projects making a real difference.
We're here at the Burley campus at Manchester Met University. Siemens have installed a large battery storage system. Together with new solar panels on the roof, it can provide power to around 900 student rooms and a large academic building. Both these new technologies are integrated into the on-site energy systems.
It's then all managed by a microgrid controller, which chooses the best source of energy to use and when the battery should store or release energy. The result? Cleaner, cheaper energy for the campus. And over at Manchester Art Gallery, Siemens have installed a brand new building energy management system, which is designed to more efficiently handle the temperature and the humidity. This not only helps protect the historic building and the works of art inside, but it reduces the energy bill by controlling the heating and cooling equipment so they're only working when they need to.
Here the team are testing a central controller with the University of Manchester and Manchester City Council. The controller integrates with the building management systems in 3 sites. It helps to reduce energy consumption in the building in response to demands on the external grid. For example, by identifying non-critical equipment that can be turned off, such as heating, for short periods during peak times.
If the controller was used all across Manchester, we could save more than 57,000 tonnes of CO2 every year. That's the same as taking 12,000 cars off the road. As you can see, there are a lot of great things happening across the city, and the Triangulum can be used as a blueprint for low-carbon, smart cities everywhere, providing more sustainable solutions to meet carbon neutrality targets.